Hello, I'm Brian Bush from the Marlowe team, and in this lecture segment, I will be providing an overview of the Marlowe command line interface. Later segments will go into more details on the CLI, but this gives you the overview. The main purpose of the CLI is to enable developers to submit transactions and interact with Marlowe contracts on the Cardano blockchain. You may be familiar with Cardano CLI, which lets you do that for simple transactions, simple scripts, and Plutus scripts, while Marlowe CLI opens blockchain interaction to Marlowe contracts. So there are a couple of use cases for it. One are the really technical use cases related to developing using Marlowe, and this would be things like measuring transaction size, submitting the transactions, testing integrations, and doing some debugging. The CLI does let you interact with the public testnet and the public mainnet if you want. We do not recommend that you use Marlowe on the public mainnet because Marlowe has not been audited yet. And you can also use this, of course, on the private Marlowe Pioneers testnet. So in general, it lets you integrate with developer workflows, and similarly to how the Cardano community has heavily integrated tools like Cardano CLI into various services like airdrops, libraries, faucets, marketplaces, things like that. And then, of course, this is useful as a learning tool, so you can really get a more in-depth understanding of Marlowe transactions. So there are really three levels at which you can interact with the blockchain using Marlowe CLI. The first is a low-level interaction, and this is really interaction that exposes the details of Plutus, because Marlowe is written in Plutus. It interacts using Plutus with the Cardano blockchain. So any workflows that give you like really fine-grained control over datums, redeemers, validators, and things like that related to Marlowe. It lets you modify the Marlowe state, Marlowe input. You can use it for adversarial testing, create sort of malicious Marlowe transactions, and you can watch the validator reject those. So this is really about Plutus. We're not going to be talking about that much here, but there's plenty of documentation and examples for that. At the high level, the CLI lets you interact with Marlowe without worrying about any of the Plutus stuff or all the details that are kind of hidden under the hood in the redeemers and datums and scripts. So this gives you a much more straightforward workflow. It automates a lot of the interaction that you would have to do by detail if you were working at the low level. And it really lets you focus just on the Marlowe contract. We have tools for interacting with the Marlowe backend. So these are the runtime services that are working behind the scenes when you use something like Marlowe Run. And so you can also interact with those with the command line tool. So it does all the UTXO management, all the wallet interaction, and things like that. So it's kind of another level of automation. It's much more complex to run. So one thing I wanted to just give a little bit of a refresh on is the UTXO model as that relates to Marlowe. So first of all, the UTXO model, which hopefully you've read about a little bit, you have transactions that consume UTXOs, and then they produce UTXO, so inputs and outputs. And if you're doing a regular non-Plutus transaction, just an ordinary transaction, you have some ADA in it, you might have some tokens, and the transaction just consumes that when you've signed it with the right private keys. In the Plutus world, there's a little bit more you have to do. You're consuming a Plutus UTXO, so it has the datum attached to it from the Plutus, and then you need to include a redeemer that will be given to the validator to spend that UTXO. So the validator looks at the datum, the redeemer, the whole context of the script, and decides whether it's okay to spend that particular Plutus UTXO. And then transactions output, they can be similar outputs to scripts. They can, of course, there's a fee, and then you can have the non-Plutus UTXOs, just the plain ones. And then the other thing that's important to know about when you're running Plutus scripts is collateral is needed. So collateral right now in the Alonzo era is a pure ADA UTXO. That may change in the future eras, but right now you need a UTXO with pure ADA, and then that can serve as collateral. That's only consumed in the very, very rare cases where a transaction is rejected, and there are lots of protections against that. So it takes a lot of effort to even create a transaction that would be failing in a way that would consume collateral because of the way the Plutus validation stages occur at the submitting node and the block producing nodes. So how does this relate to Marlowe? So Marlowe is using Plutus, as I said before. Each Marlowe contract has a currency symbol for its roles, and it has a payout validator script for receiving and dispersing payments to participants. So there are really two scripts running in Marlowe, the main Marlowe script and then a special payout script. And we'll get into details of that a little bit later. So participants interact with the Marlowe contracts typically using a role token. There are other ways to do that, but for most use cases, you're using role tokens. So these are native tokens that are sent with the Marlowe transaction that provide authorization for that particular step in the Marlowe contract. And then, as I mentioned, there's a payout script. That's a special script address where you can withdraw funds. So the main Marlowe script does not pay directly to public key addresses. It pays to a payout script, and then you do a simple authorization at that payout script to actually redeem the funds. And once again, this uses a role token, and it's a very simple payout script. The datum just says whose money is it, and the redeemer says basically nothing. So it's all just token-based authorization for these payouts. And the interesting thing is these role tokens provide a nice flexibility and security that arguably is a little more secure than just using private keys and things like that. So obviously you need the private keys and you need your wallets and stuff like that, but the roles provide perhaps a little bit extra security. And these role tokens are interesting because they can be transferred to other wallets. So you can actually give your role to someone else by transferring the role token. And you can actually use role tokens in marketplaces. You can have contracts for role tokens, so like meta contracts, things like that. So on the blockchain, we've got a couple things going on with Marlowe. First is we are minting the role tokens. So when you're starting a Marlowe transaction or a contract, basically a typical thing to do is to mint the role tokens and distribute those to the people who are going to be participating in the contract. So each of their wallets will have a role token that authorizes them to interact with the contract. This is just a minting script, so there's no datum redeemer here. The main Marlowe application script is actually generic for all Marlowe contracts. So it's a interpreter for the Marlowe language. It's slightly specialized to work with the particular role tokens, but all the logic is actually generic. The datum contains the unexecuted parts of the contract, all the balances for accounts, the history of the contract in terms of its inputs, and any current values for parameters in the contract. So the datum is really where the specialization occurs to your particular contract that you're running. And then the redeemer is actually storing the next step in the contract. So it's basically telling you the input to the next step, like what's going to happen next in this contract. And then all that information goes into the Marlowe script, and it decides whether that's a legal next step and whether the right people have authorized that. As I mentioned, the payout script, it's really just a simple script specialized to the role currency. The datum is just recording whose funds it is, and then there isn't actually a redeemer. The redeemer is ignored by the script. So the life cycle for a Marlowe contract is basically First, of course, you decide on the contract. You submit a transaction to create it. That goes to the Marlowe script address. And then once the script is there with its datum that has all the state and contract, lots of things could happen. You can continue the contract by taking actions, and those could be like making a deposit, making a choice, or notifying the contract of something. Those inputs are sent back to the script, and so when you're running a contract, you might be going through this loop quite a bit. At some point, the contract will close when it's all done, because all Marlowe contracts provably will close eventually, so they don't lock funds. And then you can also have timeouts. So these are cases where the contract proceeds without user input. It still takes a transaction to progress it in this way, but the user doesn't make a deposit or anything. They just wait, and then the contract can make a different kind of transition. And then, as I mentioned before, while things are running, periodically, and especially at the end of the contract, you will have funds sent to the payout script, and then the user can submit a transaction to withdraw those funds. So this is kind of the big picture of how Marlowe contracts operate generically. So how do you use the CLI to actually sort of study these things? So one thing you may recall is that in the playground, you can simulate contracts without running them on the blockchain. And so you can actually do that with Marlowe CLI tool too. So what you might do would be deciding on which contract you're going to use and the parameters. There are two ways of creating a contract. One is using the template commands in Marlowe CLI. I'll show you those, and that just has some sort of standard contracts you can use to get started. You can also design contracts in the Marlowe playground and download those and use them in the CLI. And then, of course, you could create contracts programmatically. You could use Python or C# or whatever language you wanted to create a contract, because a contract is just a JSON file that conforms to the Marlowe schema. So after you've got your contract, there's an initialization that goes on. So you run an initialization command that sort of bundles all the information together for the contract, because as you can imagine, there's a lot of little pieces of information that need to be organized when you're running a contract. So this basically does that organization. And then we're going now into the simulation loop, where a user decides on the next input to the contract. They apply those inputs using this Marlowe CLI prepare statement. And if the contract is not complete, then this loop goes on and on, just like in the previous diagram. Once again, you can also have timeouts with these when clauses. And so essentially, this is mimicking what's on chain. In the end, you get payments and contracts can be complete. So that's simulating a contract at the CLI. And we have a lecture segment that goes into great detail about all this, but this is the preview of that. And then what if you actually want to do more than simulate it? You want to actually run it on the blockchain. So here we have a very similar workflow, except we've just inserted this Marlowe CLI run execute. So when we were simulating, we didn't have to interact with the blockchain, but here we actually do interact with it. And the execute command takes things that you've initialized or things that you've prepared and puts those on the blockchain as an actual Cardano transaction. Everything else in this workflow is the same, except once again, with payments, you have to actually make a blockchain transaction to withdraw the funds, to move it from the Marlowe payout validator to a wallet. So basically, you can use the CLI in this sort of abstract mode where you're simulating a contract. And I recommend you do that before you try to run it on the blockchain. It's very frustrating when you have like your contract isn't designed correctly or something, and then you start executing it and it's locking funds and not working. So it's good to get it working in the abstract in the simulation mode, and then you can repeat all that and run it on the blockchain. And once again, we'll have a lecture segment on this. So back to UTXOs, what actually happens when you're doing Marlowe transactions? So there are three kinds of Marlowe transactions: creation, applying inputs, and withdrawing. So the contract starts with creation, and basically you have a role, a person who has a public key address, and they submit the creation transaction. And there are a whole bunch of outputs to this. The first thing is there's an output to the Marlowe application. So this is the Plutus script that embodies Marlowe, and it's got some minimum ADA. In this example, we have 2 ADA there. It has a bookkeeping in the datum about the balance, the history, and all the variables. And basically the contract's ready to run, and it's sitting there at the application level. This creation transaction also distributes role tokens. So you can, if there are like n roles, you might have n role tokens. And each of those comes with some minimum ADA and, of course, the specific role token. There's a fee for the transaction. With the protocol parameters right now, that's about 0.2 ADA for most of these Marlowe creation transactions. It varies a little bit depending on how wallets balance things. And then the creator gets changed, so they get the leftover funds back. So this is basically, you start with some funds and then you create a whole bunch of outputs, all the tokens, the contract, and then some change and fees. So what happens when you're applying input? This is a little more complicated because this is a Plutus transaction. You're consuming the UTXO from a previous step in the Marlowe contract, for instance, that creation step. So this has all the prior information about the contract prior to the transaction. Typically, you need to authorize this applying inputs with a role token. So you need a UTXO with that. Sorry, that's up here. And then you probably are going to need some other ADA along with that. So basically, there's some ADA, some authorization, and then the actual contract. So the redeemer is the inputs to the contract. And then once again, you get a whole bunch of output. So you get the new Marlowe contract, which is basically the old one with the inputs applied. So there's a little less for it to do. It has a new balance, new history, new variables. It's got a different amount of ADA. The submitter gets their role token back. If the contract is actually making any payments, then you will have outputs to the payout address. And so these are, once again, associated with Plutus scripts. There is a fee, once again, with the typical protocol parameters and typical transaction construction by wallets. This is usually about 1.3 ADA. And then once again, the submitter gets their change back. So this is sort of the workhorse of Marlowe. You take the prior version of the Marlowe state, do a transaction that is applying inputs, and then you get the output. And of course, if the Marlowe contract is closing, there won't be any output to the application. But in most cases, when you're in the middle of a contract, you're getting kind of this daisy chain effect. The payout at the redeemer is quite simple. You basically just have a role token, some ADA, an empty redeemer, and then out of that you get your role token back, and you get a fee, and you get your funds out. So basically, it's just pulling the funds out. So these can be quite complicated. So here's a diagram actually of an example I'll show you a bit later. And what we've done is we've animated. So each of the red circles, the red ovals, is a transaction. And so we're moving through transaction after transaction. The red ones are being consumed. The black ones are either being produced or sitting unspent so far on the blockchain. And so this particular contract involves 8 transactions and 3 participants, and there are a whole bunch of UTXOs in this. So in the later lecture segments, we're going to learn a little bit about how this works and how you can do this yourself. One interesting thing about Marlowe is the language supports something called Merkleization. And basically, Marlowe, is a very safe language, as you've heard, but it has limited capabilities, and that's really purposeful. It's for the safety. And what that means is, because it's a limited language, when you're doing a complex contract, it might become very verbose, and you can't literally fit that on the blockchain. And even if you did, you wouldn't want to like pay all the fees associated with putting a large contract on the blockchain all at once. So what we've done is added a capability to Marlowe called Merkleization. It's basically just-in-time storage of the contract information on the blockchain. So you store just the next steps, basically, in the contract, and then you have a reference to the future steps of the contract, and the reference is cryptographically secure so that someone can't change the future of the contract by fiddling with those references. So it's equivalent to running a huge contract on the blockchain, but it doesn't literally do that. So we've run very large contracts on the blockchain with very few bytes using this Merkleization approach. And so we'll talk a little bit about this later, but it's something to be aware. There may be contracts that you build in the playground that are too big to run in your web browser, but they are actually runnable using Merkleization on the blockchain itself. So that's kind of cool. Okay, getting help with CLI. We will talk about installing it a little bit, but I'll just show you there is a help command, and it kind of gives you guidance, and it's got lots of subcommands. Subcommands are first the high-level ones I mentioned that we kind of talked a little bit about before, this family of run commands, and then the templates for contracts that you could be executing. The back end has its own set of commands. We will go through these in one of the lecture segments, but they map very much to what we've been talking before, creating, applying inputs, things like that. And then we've got a lot of low-level commands. And we will not be going over these in this lecture series, but there's plenty of documentation. But if you know Plutus and you want to poke around in the Marlowe validators and redeemers and things like that, this is how to do it. You can run contracts very manually at the very finest grain level, and then manipulate roll tokens, submit raw transactions. So it gives you all those detailed access points. We have some query commands that let you query the blockchain to find the history of a Marlowe contract that has been run there, find its state, see if there are funds at a payout address, things like that. And then a whole bunch of miscellaneous commands, just kind of like wallet cleanup, some decoding, Merkleization things, a faucet that works only on the private test nets, and then a chainsync follower so you can watch what's going on live in Marlowe. So troubleshooting, I think the main thing to remember, and you've probably experienced this a bit using the playground already, is, pay attention to the simulation. Do a careful simulation of your contract. When you're designing contracts, pay attention to the timeouts, the when clauses, and how funds would be dispersed when things time out. We have many resources here. So this main CLI documentation, our repository, there are Cardano docs for this. You've been using the playground and run. And so there's a lot out there in addition to like the Discord channel and things like that. And then I'll just give you a quick summary. So we looked at how the CLI can be used at various levels in the blockchain, that you can run contracts without actually making the blockchain transactions, or you can run them and make the blockchain transactions. And if you're running them on the blockchain, you can do like kind of the Plutus is hidden, or you can do very Plutus aware approaches to that. We also have a back end here in Marlowe that you can use. And then really the three things you do on the blockchain are create a contract, apply inputs, and withdraw funds. So that's where we are right now. We'll talk a little bit in future lectures about installation, doing the simulation, submitting things on the blockchain, and then actually running the transactions. So thank you.